All right, let's try this again. Class.
Yes.
Better. All right, linear speed to English speed. So you're going to get less talking from me. Blam. It's all this. Speed, linear speed is distance over time, which is v is equal to s, my distance, divided by time. Angular speed, which is my w here, which is my angle theta in radians divided by time. And we're going to have all these right here. So when we do these problems, you're going to list all these items. We're going to have w. So we're going to have w, theta, and t. And over here, what else? We're going to have v, s, t, r. What do you think r stands for? Radius. Very good. So there's 3 different ways to calculate my linear speed. 3 different ways to calculate it. So we always want to use what's given to us. So if I'm giving you s, the distance, and time, are you going to try and find velocity by doing r times w? Say no. No, you use the variables that are given to you. Now, this probably doesn't make any sense at all. It's probably really annoying. Let's try the problem. Suppose point P is on a circle with the radius of 10 centimeters. All right. Bless you, I think.
Thank you.
All right. So, what information is given to us so far? The radius. So, my R is 10 centimeters. And ray, OP, is rotating with an angular speed. Ooh. Angular speed. What variable is representing angular speed? W. If you didn't know that, you could back up a slide. So W is pi over 18, and it's speed. It's speed, right? Speed is a distance over time, but this one is an angle over time, and that's rad per second. All right, find the angle generated by P in 6 seconds. All right, I have P, I'm sorry, not P, time. P is the point that is actually moving around that. So my time is 6 seconds. Now, let's list the things that I don't know. We're going down all my variables. So RWT, I got those ones. So this one, find the angle, so I'm looking for theta. I'm looking for theta there, right? What's another variable that I don't have? P is the point. So if we're talking about the circle here like this, and it's starting and it's going this way, they're calling this one right here point P as it's traveling this theta. So P is the point on the edge of the circle. What else am I missing? Am I missing pizza crust? What? Maybe. What variable is used for pizza crust? What?
Distance? No, S.
S. S is my distance. S is the pizza crust. So we're missing the S. What's another variable I'm missing? You guys can go back and look. Here's the variables, right?
Uh-huh.
Do we know W?
Uh-huh.
We look for theta. Do we know time? Good. Okay. Do we know V? We don't know V, right? V is an unknown. V is also a unknown. R theta T, R WV. So all those are accounted for on here. We're going to find all of these. That's the reason why I said I want you to list them all. You're going to have to find them all. Okay? Say yes.
Yes.
Good. That's what I'm looking for. I need to find them all. Kind of like Pokemon. We got to catch them all.
Let me see.
Good. So I'm looking for theta. All I have is R, W, and T. So R, W, and T. So what formula can I use that has a theta in it that also has an R, W, or T? Am I speaking a little bit too complicated here?
That's just a lot of variables.
I'm looking for theta, right?
Yes.
So in algebra, I need to pick one of these that has a theta, right? That would be this one here, isn't it?
Or that other one.
Or this one over here, right? Okay, let's start over here on the right-hand side. So you could only do algebra if you only have one unknown variable to solve for it, right? So you could solve for it if you know everything else. Do I know the V? No. Do I know R? Say yes. Do I know the T? Yes, I do. So in this one, I cannot use this because I don't know V and I don't know theta. Does that make sense? Yes. Now let's look on the one on the right. Angular speed. Do I know the W? Do I know T? And so that means my only unknown is theta. So I'm going to use the formula W equals theta divided by T to try to isolate what my theta is. So W equals theta over T. My W was pi over 18, right? Yes? Equals theta over my time. What did we say time was?
Yeah.
6 seconds. So I'm going to put 6 right there. So now it's set up, I only have one variable. So what would I do to get the 6 out of the bottom of the right-hand side?
Multiply by the reciprocal.
Multiply both sides by
The reciprocal.
6, right? Or 6 over 1 if that helps, right? I'm going to multiply both sides by 6, and on the right-hand side, what's going to happen when I do that? Starts with C, ends in Ansel.
Oh, yeah.
Very good. So I'm canceling those. So I'm going to get theta equals, now, this is going to multiply and become 6 pi over 18. But now I need to be able to reduce my fraction.
Oh, you can reduce it by a factor of 3, I think, right?
Yeah, you
Or
could.
2.
And can I reduce it by a factor of 6?
Oh, yeah, you can.
Yes, I can. So if I reduce it by a factor of 6, on top I'm left with just
Pi over 3.
pi, and 18 divided by 6 is 3. And that's going to be my theta. Is that not too bad there, right?
No.
Not too bad. So, like I said, some algebra was involved. There we go. So we got this one, and we said that one is pi over 3. So the next one over here says find the distance traveled by P in the circle 6 seconds. Distance. So now let's go over here. Now distance is what variable?
Distance is S.
Very good.
Over T.
Yep. Distance right here. Distance is the S. So I'm going to have V equals S over T. Is there any more S's here? There's no more S's. So, but I got a slight issue here. Since I know I'm looking for S, I also have to have V, don't I?
Yeah, but you don't have
You don't have
Can I find V?
Yeah,
Yes, I can.
probably.
Let's solve for V first. Now, looking at those three, what information do I have that I could use to solve for V?
You have R and T.
You have
So
R and theta.
yeah, you have
I have R, theta, and T, don't I? Hey, I could do it there, but do I also have R and W?
Yeah, and you can just use that one for this.
I could use that one also. So because I already have enough information, I'm gonna just use this one here on the bottom to make it a little bit easier. So I'm gonna use that one. I'm gonna solve for V there. So we say V equals RW. V equals R. We said my radius was,
10
and my W was?
pi over 8.
Very good. Let's go. And V stands for velocity. Velocity is a distance over time. It is a rate of change. So when I add this to here, don't forget, my answer, which is going to be velocity, is going to be moving over time. So it's going to be whatever the seconds are on this. And it's per second. Because my W, my English speed, also has a angle divided by time, right? And that was per second. So if I were to multiply this out, I get V equals 10 pi over 18. And I could reduce that fraction now
By factor 2.
by 2.
I think that's it, right?
Yeah, just 2. And what do I get if I divide 10 by 2?
5 pi over 9. Is that what that is?
Yeah, 5 pi over 9. So that is my velocity. But what are my units here?
Seconds.
So it's rad per second. That's important because we'll eventually get to stuff that it starts off with degrees, or it's going to ask for degrees later on, and you're going to have to convert it. But make sure you label what it is we're talking about all the time. So V. So 5 pi over 9 rad per second. All right, so now that I know that, now can I solve for my S?
Oh, yeah.
Yeah, it's right here, right? So now I gotta solve for S. So I now know what the V is, I know what T is, and I can solve for S. So V equals S divided by T. My V is 5 pi over 9 times S, equals S divided by time, which was 6. And I want to get rid of that 6. How do I get rid of the 6?
Multiply by the reciprocal.
Multiply both sides by the reciprocal, which is 6 over 1. So let's see, it's going to turn into S equals, because those cancel,
30 pi over
30 pi over 9, but I'm pretty sure that could reduce
9.
by 3, isn't it? By 3, if it reduces by 3, that would become
10 pi over 3. Yeah, right.
10 pi over 3. Now, S is a distance, isn't it? S is distance. What was the distance? What units was my distance? Centimeters. Very good. It's centimeters because if we go back to the problem here, it says right here, R is in centimeters. So that means that all of my values are going to be in centimeters. Just like over here, W was radian per second. That means all my times are in seconds. That's how we base that on. So we had 15 pi over, no, it wasn't 15. What was it? 10 pi, right?
Nah.
And my units. So if you want to make yourself a note, this is helpful. Distance needs to have units, right? Time, also units, because that's time in seconds, hours, minutes, whatever it is. Theta has to be in. What mode's theta? Radian, right? Okay, W, which is my angular speed, is going to be radian per second. My radius also has a distance. Ooh, I think I messed up velocity. Yes, I did. Why didn't someone correct me on velocity?
I don't know, 'cause it seems right.
Velocity. So, it's distance over time, isn't it?
Uh-huh.
What was my distance? What's my units for my distance? Centimeters. Centimeters. So this is cm per second. Because this one over here, angular, is my radian per second. Questions, concerns? Did I mess you guys all up? Oh, okay. So, it's a lot of algebra. You have to find everything that's on the list. So if you notice, I have all this on this first page. Right here, B, we found that in 6 seconds was the distance, so S was
10 pi.
units,
Centimeters.
centimeters, very good. And C, I didn't even talk about C, right? C is the one that we had to do even before we get to B. So we have to do all of them first and then fill in our answers. Because part C says find the linear speed. Wasn't linear speed V?
Yeah.
So V was,
5 pi over 9.
and if you notice right here, centimeters per second. That's important because I messed up on mine. So yes, I'm doing it kind of out of order, but I do everything first. I solve for everything I can, and then come back and answer the questions. Does that make sense or no?
Yes.
Good. Example 2, and then I'll leave you alone. A belt runs a pulley, radius 6 centimeters, at 8 revolutions per minute. A belt and a pulley. So let's say, for instance, I have there we go. All right. Come on. There we go. All right. Okay, radius 6 centimeters. $80 revolutions per minute. What is 1 revolution? What is it? It is 360, but are we dealing in degrees? We're dealing in radian, right? So what is the whole circle in radian?
The whole circle, so pasa de the circle with
What is it? Say it again.
Say it again.
A whole circle's how much? In radians, 2 pi.
Oh, hang on.
It's 2 pi.
I do.
Then why didn't you bust out yours?
Oh. Cause I should do it. So like, what's the point?
Anyway, so a whole circle in radians is 2 pi. Yes?
Uh-huh.
Good. And 1 revolution is 2 pi, right? But there's 80 of those. 80 revolutions, I would take 80 and multiply that by 2 pi, right? Because every single one of those revolutions is 2 pi. So my revolutions is going to be all together 160 pi. So, and that's per minute. So let's see, 160 pi per minute. What variable does that go with? It is W? Because it's the angle over time, right? It's an angle divided by time. There we go. Per minute. So that's going to be my W. Find the angular speed in radians per second. Ooh. Like I said, units are important. So let's go ahead and all my variables. Let's go down and list all my variables. So I have R, W, I need theta. I need theta, right? What else do I need? S,
V,
V, anything else?
T.
T. That's going to be all of them. Like I said, start these out by listing everything you have, and now go back and look at what you could solve for. So what can I solve for automatically, even though I'm probably not solving my questions in order? What can I automatically solve for if I know the W and the R? I can solve for velocity, can't I?
Yeah.
That one should be an easy one. Insert. So we have velocity is equal to RW. Since I know the R and I know the W, that one should have been the one that you picked out right away. All right, let's plug it in. So velocity is equal to R. What was my radius?
6.
Very good. Times W, which is 160 pi, isn't it?
Okay.
Do the multiplication.
Pi.
And that's going to be what are my units? Centimeters?
Yeah.
Per what?
7.
Minute.
Per minute. Right now it's still minutes, isn't it? It's still in minutes. So that's what I have to look at next. So did that make sense so far, right? Now I need to do a conversion. So I'm going to show you guys how to do unit conversion pretty basically. 960 pi centimeters over 1 minute. So to do a conversion, I'm going to multiply. What am I trying to get rid of here? Trying to get rid of the minutes, right? So I'm going to multiply by a fraction. If I want to cancel out the minutes, where am I going to cancel it out? Looking at this fraction over here, top or bottom, right? Say yes. So that's where I need to also have minutes. So we have minutes here. So I want those to cancel out. Say yes.
Yes.
I want those to cancel. So now what am I turning my minutes into?
2nd.
Seconds. So down on the bottom is going to be seconds. Now think about it. These two are both the same thing. It's got to be the value of 1. Where are they both the same? When 1 minute is 60 seconds. 1 minute is 60 seconds. They're both the same right there, right? They're both the same. So I'm really not changing the value. I'm changing the way it looks. I'm changing the units I'm using. So my minute and minute will cancel, right? And then it's going to be 960 pi centimeters divided by 60 seconds.
Pi.
16 pi. Very good. And so my velocity, what are my units on my velocity now?
Seconds.
16
7.
pi Very good. Centimeters per.
second.
There we go. So now we have everything in seconds now. So I can go ahead and put that on my other page. Okay. Angular speed is the W. We already have that, but we need it in seconds, right? So right now we have W in minutes, don't we? So let's convert this one now, doing the same steps to convert the W into radians per second. I want you to do those steps. So you're going to convert this into radian per second now, using the same step that we just did. All right, I'm going to set up mine. Again, I'm going to convert using the same method because I'm getting rid of my minutes. So 1 minute is on top and 60 seconds is on bottom. So my minutes cancel. 160 pi, that's my rad, over 60 seconds. And what'd you come up with?
Attention seniors, FAFSA Fiesta is during lunch in the South Gym. You must have your green ticket to enter. Attention seniors, FAFSA Fiesta is in the South Gym during lunch today. You must
8 over
have your
3,
green
that's
pass to enter.
2.6.
Thank you.
2.6? Yes, no?
Oh, I know, my calculator just put 8/3.
8/3, right? Okay. 8 over 3 or 2.6 pi, and that's going to be rad per second.
Oh, that, if you want it in a decimal, it's just 2.6 repeating.
Yeah.
Yeah.
So we get the W here now. I'm going to go back and change this. So let's see. So I've changed the W into the units I'm supposed to get.
Like way too big.
There we go. And so we need to solve for, so we know RWV, so I need to find ST and theta. Find the linear speed. Linear speed is which variable? The V, right? Okay. So let's go back and look. Which one am I going to use for this one? I got RW, don't I? So RW, I got my V already, right? There we go. So for part B, I already solved for my V because that was the easiest thing to get next. And what did we say that was?
16.
16 pi over no, 16 pi centimeters per second. I'm sorry. There we go. 16 pi centimeters per second. And that's it. So we didn't have to go through and find all the other variables, but could we have? Yeah, we could have. Depends on what's given to you. All right, I'm going to leave off here and give you guys a little bit of time. Tomorrow, I think we have like one more example to do, and then that's it, and then you guys are going to finish this up. All right, make sure you guys like, share, and subscribe. Hit that notification button, and support my channel. I did not post my new socks, but I will. I'm still working on it.